right, what about if you have radical functions? So radical functions, you kind of got to be careful with graphing those. I would still suggest picking, different ordered pairs, but I would kind of keep your domain and your range in the back of your mind. So take something like this one. In terms of your domain, keep in mind you do not want numbers that are going to be less than 4. You want x to be greater than or equal to 4. Now, 4 is a good number to plug in because when x is equal to 4, notice that y is going to be equal to 0. So if we're making a table here, if I plug in 4, 4 minus 4 is 0, square root of 0 is 0. So that's going to be kind of my starting point. Now, I don't want to pick anything less than 4 here because if I did, I'd end up with a negative. So let's pick some numbers that are greater than 4. I do want to kind of it to be pretty because if you plugged in something like 7 minus 4 is 3, and the square root of 3, I mean, you could try graphing it, but it's going to be a decimal. What happens if I plugged in a number like 8? Remember, 8 minus 4 is going to give me the square root of 4, which is actually going to be a pretty number. I like to keep my ordered pairs pretty if I can. Now, when you graph like radicals, square roots, cube roots, etc., they have this curved shape, so either curve off to the right or it's going to curve off to the left. Let's look at another example here. Think about what you want your domain or where kind of your starting point to be. What could x be equal to? Well, again, we don't want it to be equal to a negative. So we know in this case our starting point is going to be 0. So x could be greater than or equal to 0. It couldn't be less than 0 because that's going to give me a negative. So considering that 0 is my starting point, if x was equal to 0, what would y be equal to? 0 plus 2 is going to give me 2. So this is my starting point on my graph. Let's pick another square root that's pretty. What about if we plugged in 4? So the square root of 4 is 2, and then 2 plus 2 gives me 4. So when I plug in 4, I actually get 4 for my answer here. So this is 4, 4. Unfortunately, I don't have another, well, I could do 9. Let's do one more just to be on the safe side. The square root of 9 is a pretty number. Square root of 9, oh, excuse me, I jumped ahead of myself. The square root of 9 is 3, and then 3 plus 2 is going to give me 5. So 9, 5 would be another ordered pair. Oh, it's right there. Sorry, guys. So I think I have enough at this point to connect these dots and then draw my little arrow. Let's look at function notation. So there's some problems in which you're given a function and it's asking you to plug in a value. These are essentially plug and chug questions. Now, one thing you can do, if you know how to do this on your graphing calculator, you can put this in for your y equals and then hit second and then graph, and it's going to give you a table of values. So what you could do is scroll to find these values, and then you'll have the corresponding y value here. If you want to do it by hand though, if I plug in 0 for x, this would be 2 times 0 minus 1. So this is going to be 0 minus 1, so f of 0 is going to be equal to negative 1. Now it wants me to plug in negative 2 for g. Here you do have to be kind of careful because you're squaring negative 2. I always tell students when you put negative 2 and you square it, make sure you put it in parentheses in your calculator. Otherwise, your calculator is not going to take that negative with it, which is going to give you a different answer. So negative 2 squared is going to be 4, and then 4 minus 4 is going to give you 0. So g of negative 2 is going to be 0. If I plug in negative 1 here in the f of x function, this is 2 times negative 1 minus 1. So this is negative 2 minus 1, which is going to give you negative 3. So f of negative 1 is negative 3. And then finally it wants me to plug in 3 for the g function. So I've got 3 squared minus 4. So this is 9 minus 4, which is going to give me 5. So g of 3 is equal to 5. Last but not least, let's talk about function operations. So this is either adding functions, multiplying functions, subtracting functions, dividing functions. So some examples of this. If it asks you to add the two functions together, simply you just rewrite them as one big function being added together. So this is plus negative 4x plus 1. You can combine like terms, which is going to just give you negative x, and then 3 plus 1 here is going to give you 4. So f plus g of x is going to be the function negative x plus 4. Again, you're just combining them together. Now, if it asks you to multiply them in this case, do be careful. What this means is taking 2x plus 4 times negative 3x plus 2. So you do have to use the full method or distribute, however you want to look at it. So this is going to be negative 6x squared. Distribute this guy is going to give me plus 4x. Distribute here is going to give me negative 12x. And then 4 times 2 is going to give me 8. So this is going to give me negative 6x squared. This is going to give me negative 8x. And then plus 8. Now if it asks you to divide, you're taking that first function here, f, and you're dividing it by 2x. Keep in mind, when you divide polynomials by a monomial, what you're essentially doing is taking every piece of that first function and dividing it by 2x. So this right here is going to give me 3x. The middle just cancels, which is just going to cancel to give you 1 because those two cancel each other. And then negative 4 over 2x, that can be reduced down into negative 2 over x. Notice the x here did not move. It stayed in the denominator. You can't just move it to the numerator. So if you do have a variable in the denominator, keep it where it is. Subtraction is probably the trickiest of the four. And the reason being is you really want to make sure that you're careful what order the question asks you to subtract. So like in this case, it's saying g minus f. So I'm starting with g, which is x to the third plus 2x, and I'm subtracting f. But notice how I write this. I'm not just subtracting 4x, I'm subtracting 4x minus 3. This makes a difference because that subtraction has to be distributed to everything in that second function. A lot of students make the mistakes of writing this as x to the third plus 2x minus 4x minus 3. But it's minus 4x, and then what's going to happen here is when you do that negative times a negative, this is actually going to change to minus 4x plus 3. So now I'm going to combine like terms. This is going to be negative 2x and then plus 3. If you have any questions about functions, please do not hesitate to ask.